Two cups in your system. You bad and you know it. Don't be afraid to show it off.
All right, so now we're getting into flow rate and drops per minute dosage calculations. Let's focus on the flow rate first. The formula for flow rate is the volume, which is typically in milliliters. That's all I've ever seen a problem measured in is milliliters, divided by the time in hours. Whenever you hear the phrase flow rate, just think of milliliters per hour. And the answers to these questions are answered by rounding it to the nearest tenth. So it's pretty straightforward. You just divide the overall milliliters of the medication order, and then you divide it by however many hours it is infusing by. So let's try an example. The doctor orders Zantac 150 milligrams and 175 milliliters of D5W, and it's going to infuse over 45 minutes. Now, these are a tricky question because it says 45 minutes. It doesn't give you a straightforward hour. So something you can do is 45 minutes, that's an increment of 15. And you know that 15 goes into 60 4 times. And I got 60 because there's 60 minutes in an hour. You got 15, 30, 45, 60. So what I do is you put this in decimal form. So 15, that's only 1/4 of an overall hour. In decimal form, that would be 0.25. For 30 minutes, it'll be 0.5. For 45, it'll be 0.75. And then for an hour, obviously that'd be 1. It'd be 1 hour. You wouldn't put it in a decimal. Since this is 45 minutes, what we have to do is we have to use 0.75 because it's 45 minutes is the equivalent to 75% of an hour. So when we're setting up this equation, the doctor is ordering 150 milligrams, which essentially you can disregard, in 175 milliliters. That's what we need. We get the volume. So you put 175, and it's infusing over 45 minutes, which is the equivalent, to 0.75 hours. So you put 0.75. This here's the drop factor. That's irrelevant for these sorts of questions. We're not going to utilize this until we start calculating drops per minute. So for this, you put this in the calculator. Do 175 divided by 0.75, the volume divided by the amount of time in hours. And that's going to equal 233.3 repeating. Now, as I said prior, flow rate questions are rounded to the nearest tenth. 233.3, the number after that 3 is another 3. Since it's less than 5, we round down. So we would just keep 233.3. We wouldn't round up to 233.4. So that is what the answer is for this. It'd be 233.3 milliliters an hour. And that's the answer to that one. Let's try another question. This time the doctor is ordering the infusion of 250 milliliters of platelets IV over 2 hours and 30 minutes. What we have available is a drop factor of 10 drops per milliliter, but that's not something that we're going to worry about because this isn't a drops per minute question. We don't need to, so you can disregard this just like before. We don't need that. The question is asking what flow rate, or milliliters an hour, like I told you, that's synonymous with flow rate, will you set on the IV infusion pump? So same exact thing. We use the volume in milliliters divided by the amount of time in hours. So the doctor wants 250 milliliters of platelets. So we're going to put 250. You put in a little line to set up your fraction. See, this is far more straightforward than the other one. This one says 2 hours, so you know it's going to be 2, but then you have 30 minutes here as well. And what do we establish up here? 30 minutes is the equivalent to half an hour. You can do a lot of this in your head as well. So it would be 2.5. Now, I probably could do this in my head, but it's okay. You do 250 divided by 2.5, and then that's going to equal 100. It was pretty straightforward, pretty easy. 100 milliliters an hour is your answer. Now, let's revisit those formulas before we attempt a drops per minute dosage calculation question. The formula for this is the volume, which is in milliliters usually, times the drop factor divided by the time in minutes. So this time we're not dividing by the time in hours, it's the time in minutes. And something that you should remember is that drop is rounded to the nearest whole. And a good way to remember that and, stick that in your brain and differentiate between the two is that, you can't really have half a drop, It's either 1 drop, 2 drops, 3 drops. So think of it like that, in order to simplify, to make it easy for you to remember that rounding rule and guideline. And also remember your abbreviations. GTT, that's the equivalent to drop. You need to know that. So let's try an example. Let's knock out this first one. All right. The order is to infuse 2,750 milliliters of 0.45% of normal saline at 150 milliliters an hour. The drop factor is 15 drops per milliliter. How many drops a minute will you regulate the IV? So we know that the volume is 2,750, so we can write that. Remember your formula. Volume times the drop factor divided by the minutes. So we know that the volume is 2,750. Now what we need is the drop factor. The drop factor is 15. You multiply that by 15. Now what we need is the number of minutes. This does not supply you the number of minutes. This just tells you that it's 150 milliliters per hour. So what we're going to do, this is in milliliters, this is in milliliters. We're trying to figure out how many hours this is, and the overall infusion time, the overall infusion volume is 2,750. So what we're going to do is we're going to divide the 150 by this so we can get the hours. So you do 2,750 divided by 150. And you're going to get 18.3 repeating. So let's just round that to, well, we won't even round it. We'll just stick with this. Now the point of us dividing 2750 by 150 was to get the hours. So essentially the infusion time for this problem is 18.3 hours. So what you do, well, how many minutes are in an hour? Because we're looking for the minutes so we can divide. There's 60 minutes in an hour. So you would divide this by 60. Hold on. There we go. You would do that 18.3 repeating. You multiply that by 60 because the 18 is representative of the hours. There's 60 minutes in an hour, so you multiply the 60 by the 18.3 and you get 1,099.9 repeating. So what I do, I'll just round this up to 1,100. So let's just say that's 1,100. Let's cancel the calculator out. So now you got 1,100 minutes. That was the minutes. The 18.3 is the hours times 60. So you got 1,100. That's your minutes. So now we can put all this in the calculator. Let's do 2,750 times your drop factor of 15. That's going to equal 41,250. You divide that by the minutes here. You're 1,100. And then you get 37.5. But before you conclude this is your answer, remember, you're not going to regulate the IV by saying, I'm going to have the IV drop 37.5 drops a minute, 37.5 drops. It doesn't make sense. You round this up to the nearest whole. So it would be 38 drops a minute. And that is your answer. All right, let's try another one. So the doctor orders Cefoxin, 0.5 gram, and 275 milliliters of D5W to infuse IV piggyback over 2 hours. The drop factor is 60 drops per milliliter, how many drops a minute will you regulate the IV? So this one's pretty straightforward. So, we refer back to our formula. You take the volume. The volume is a totality of 275 milliliters. That's your 275. You multiply that by a drop factor of 60. Set up your fraction. And then the time in minutes. This says an infusion rate of over 2 hours. Well, that 1 hour, 60 minutes times 2, that's 120. So we got that there. You put your 275, you multiply it by the 60, you get 16,500. You divide that by 120, and you get 137.5. So 137.5, just like before, drops are rounded to the nearest whole. 138 drops a minute. And there's your answer.